All right, today we have all the operations with polynomials. I'm going to add them, subtract them, multiply them. Well, I guess not all of them because we're not going to divide them, but polynomials look like what you see down here at the bottom of the slide. This one has two variables. Most of them we're going to work with today have one variable, meaning they may have different exponents, but just one variable in them. And that's what this slide's about. If they're in one variable, there are four terms you really need to know, and these are really important, so make sure you get these down. Again, one variable because it's all just x's in there. Leading coefficient is the coefficient of the term with the biggest exponent. So in this case, the leading coefficient would be 2 because it's with the fourth power. It's the coefficient, not just the first one all the time, unless you have them in decreasing order already or descending order. The constant term is a term that has no variable with it. In this case, it's negative 12. The degree, if it's a one variable polynomial, is the biggest exponent. It's the greatest exponent. In this case, it's 4. And descending order just means that the terms are listed in terms of greatest exponent down to smallest exponent. And the one up here, the example on the slide is, it goes 4, 3, 1, and then 0 or no exponent. Okay, the first set of exercises is going to be find the degree, and these are one variable polynomials, so it's just the biggest exponent on the variable, I should say. So part A, the degree is 3. On part B, the degree is 4 because it's the largest exponent. Now C is kind of weird because there's no variable. And when there's no variable, the degree is degree 0 because it would be like x to the 0 power. The next thing we're going to do is add or subtract the polynomials. And this is very, very simple, especially the addition one. You're just going to add and subtract the like terms. So I'm going to kind of underline these two. And because there's the addition sign in the middle, I'm going to go ahead and just add straight across. So I'm going to say negative 5 plus 12 will be 7x cubed. These two are also like terms. 3 plus negative 7 is negative 4x squared. And then I have these also. Nope, they're not like terms. I made a mistake there. Mistakes are okay. I'm going to make a bunch of them. So I'm just going to bring down the negative x and also bring down a positive 3. Notice it's in decreasing order, which is great. And that's all you do. Now, when it's subtraction, you may want to do one extra step. I do this a lot. I'm going to take both sets of polynomials out of their parentheses. But the second one, because there's a minus sign, I'm basically going to distribute that minus sign through the second parentheses. So it changes the signs of everything inside. So it's going to take that 5x squared y cubed and make it a minus 5x squared y cubed. It's going to take the minus 4xy and make it a plus 4xy. Then I'm looking for my like terms. There's 2, because they're both x squared y cubes. One is 6 minus 5. 6 minus 5 is 1, x squared y cubed. And then I have this. I have the negative 9 and a positive 4, which is a negative 5xy. And that's all you can do. Not too bad at all. Okay, multiplying. Last thing we're going to do today is multiplication. These are just called monomials because just one term. If you notice in A and B, there are no addition or subtraction signs in there. And when that's the case, you just multiply straight across. So I'm going to start with the coefficients here. Negative 2 times 5 is negative 10. Don't forget your exponent rules from yesterday. Add your 3 and your 4. That's 7. Go to part B. Part B, again, multiply your coefficients. That's 24. And I'm adding my exponents because I'm multiplying. On the y's, I have a 1 and a 3. On the z's, I have a 2 and a 5. And I get 7. So not a big deal there either, I hope. Okay, it gets a little different here. The general rule for multiplying polynomials is, when they're in parentheses like this, the general rule is you have to multiply every term in one parentheses times everything in the other. And what I will look to do most of the time, I'm just going to look backwards maybe when I do this. I hope it doesn't. I'm usually going to take the smaller of the two parentheses and take it through. What I mean by saying that is I'm going to take the 2y and distribute it first. I'll go ahead and do that. So I'm going to do 2y times the first time. 2 times 4 is 8. X fourth, y squared. I think I'm writing too big here. Take the 2y times, I'm taking the 2y now times the 7x squared, which is going to be minus 14 x squared y squared. And then I'm going to take the 2y times the 3y and have 6y squared. Now I'm going to do the exact same thing with this term. I'm going to take it times the 4 x fourth y first, so it's going to be negative 12 x to the 6th y squared. Then I'm going to take it times this one. 3 times 7 is 21, positive 21 because they're both negative. 21 x to the fourth y squared is supposed to be a 4. There we go. Run out of room. Maybe move this over just a little bit. And then the 3x squared times this one, which is negative 9x squared y squared. And now I'm looking for like terms anywhere. And one thing I see right off is I see these two. Both have x to the fourth and y squared. This one, I don't see anything that matches it. And because the x has the biggest exponent, I'm going to go ahead and write it first. I'm going to put the negative 12 x to the sixth y squared first. Now I'm going to add the two right here that are like terms. I have an 8 and a 21. 8 and 21 is 29 x to the fourth y squared. Then I also see these two. I see that 14x, 14x squared y squared, negative 9. They're both negative. So it's going to remain negative, and negative 9 and negative 14 is negative 23 x squared y squared. Notice my exponents are staying the same. They don't change when you're adding. And then I just leave the 6y squared to go here. Notice my x's are in decreasing order, which I like, or descending order. And that's probably the longest problem you're going to do today, to be honest with you. Okay, this one I think you might remember from Algebra 1 or even geometry. We're going to use FOIL. And you tell me what these are called binomials because there's two terms in each parenthesis, so it's a binomial. So I'm going to follow FOIL. F stands for first, which are these two. 2x times 3x is 6x squared. I'm going outer. Outer of these two. 2x times 4 is 8x. I stands for inside. I'm going here, negative 21x. And then L stands for last, which are the last two in each parentheses, negative 28. If you notice what FOIL does for you is it puts your like terms in the middle, which makes it easy to add them together. So I'm just going to bring down to 6x squared. 8x minus 21 is negative 13x, and then a minus 28. FOIL method. Hopefully that's a review for you. All right, one more slide. Squaring. There's a great shortcut for squaring. I'm going to give you a gesture for this tomorrow that'll really help you, I believe. I'm going to show you one the long way, and then I'll try to show you a little bit of shortcut. Yeah, so squaring is something that means you're multiplying it by itself. So if all else fails, you can always write this thing twice. 4x plus 1, 4x plus 1. Do FOIL. You would get first. That's an x squared. Let me do that again. Let's see here. Sorry about that. X squared, outer, inner, and last. And then, of course, you can add the two in the middle, the two terms in the middle. 8x plus 1. That's the long way. That's the FOIL method, which isn't real long, but it's the long with the two methods. So the other way is there's a shortcut that says this. You can square the first term. If you square that, you get 16x squared. You can multiply these two terms together and then double it. So if you do 4x times 1, that's 4x. If you double it, it's 8x. And then square the second term. If you square 1, it's just 1. I'm going to do that on the second one right here. So again, the shortcut. Square the first term. If you square that, you get 9y to the fourth. Multiply these two terms together. We give you negative 6y squared. Double it, you get negative 12y squared. And then square the second term, which will give you a positive 4. And the last one, if you notice what's in these, just not squared. A lot of times I'll refer to these as conjugates, and we'll talk about that tomorrow in class. If I do FOIL here, I would get, if I do the first, I shouldn't have done that arrow too quick. I get first, then if I go outer, I get negative 3x squared y. If I go inner, I get plus 3x squared y. And if I go last, I get negative 9y squared. And what happens in my middle terms, they're opposites of each other. They're just going to cancel out. So you get x to the fourth minus 9y squared. So when you see conjugates, when you see the same thing in each parentheses, except the sign's different, please realize that the middle term is going to cancel. So really, instead of FOIL, you can just do FL, and we're going to call it because that's what it says. You just do the method if you have conjugates or the same thing in each parentheses, except the sign is different. The only thing that's different. All right, hope that helped a little bit. Hope you got some good notes. We'll work on all this stuff tomorrow, and I look forward to seeing you then. See ya.